So Virginia Space has the ThinSat program where they're allowing schools, universities, high schools and middle schools an opportunity to design and build the electronics that will go into a satellite that goes into space.
So a ThinSat is a type of small sat that is equivalent to the size of a slice of bread. But that's not all we had to work with. We had much less. Take that slice of bread, cut it in half to about this size, and that's the size of our payload that we had to work with. So it was very tight, but we made it work.
It was really interesting. We got on a conference call with people from Virginia Space and NASA over at Wallops. And I just thought that was really cool. I was ecstatic about the idea of putting something into space. I was like, wow, something that I'm working on is going to be in space.
My initial half of the science was to determine if there was a connection between thunderstorms and other weather phenomena and see if there is that connection to the magnetosphere to look at the magnetic changes in that flux. So the other half was to try to detect STEVE. That stands for Strong Thermal Emissions Velocity Enhancement. And what this is what was initially detected as an aurora. It's something a little bit different, but it appears as an aurora. And this STEVE it's this new science. It's new, discovered in 2016 was when it first detected, and when they realized it actually wasn't something that belonged to Aurora Borealis. So we tried to put that RGB sensor in it so that we could try to capture pink or red colors and compare that to what latitude or longitude our satellite was being over to see if we could somehow make a connection with spottings on the ground.
It was really fun and exciting. Not every day that you'd get an opportunity to design and build something that goes into space. But it wasn't just that, right? Because the students were getting a pretty thorough engineering experience. They had ideas for what they wanted to do and an interface control document that told them how to, the limitations of what they could do. And from there, they had to design and build it. And they also got an opportunity to work with engineers at Virginia Space. So after they designed, they had a design in their minds about what they wanted to do. They presented it to the engineers at Virginia Space, and they made suggestions on how to improve it and make it more realistic or more able to work out. And so they helped us iterate designs, and then they actually got to build it.
Being able to actually watch the rocket go and know that it's something you worked on, it's honestly a little indescribable because I've seen so many different launches, but it's this sense of pride that you can only get at the end of this project. And also afterwards, just being able to sit down at the computer in the trunk of my car and we all just stood around waiting for that data. It was an experience I won't want to ever trade or give up, just because it was that accomplishment, because it was such a long timeline to get to where we were.
Stage 1 continues nominal performance, engines at 100%.